Okay, for today, we're doing a little bit more on law of sines, and so we're doing some review, and we got answers of 28.8 and 111.2. Raise your hand if you had the same thing. Okay, good. I'm just going to take 2 seconds to set this up. It would be sine of, which one's A and B and C? Does it really matter? Could I pick this to be C and C? Yeah, I could if I want to. I could pick it to be A and A, okay? But that's an important moral of the story on this. You remember how in the other triangles, one of the sides had to be C because it was the hypotenuse and it was a big deal, and the other two squared added up to that squared, and like, do you get how now it really doesn't matter? Because they're not right triangles, so all the angles can be different, all sides can be different. All right, so I'm going to pick this to be big A, and that would make this little a over here, okay? And that would be 20 over sine of 40 would equal, and then the ones I would probably want to work with would be this and this first. Okay, so I'm going to call this big C and little c. And that would be sine, 15 over sine of little c, or big C. I kind of made it medium size. I got to go with big. All right, so sine of big C. And then you would cross multiply and solve. This would be 20 sine C equals 15 sine 40, and then divide by 20 on both sides. And in the end, that's your thing that you're trying to find, but you go inverse sine of both sides to solve it. So we go inverse sine here and inverse sine here. So inverse sine of all that gives you your answer. Okay, let's move on. What's wrong with me? Well, this one, when you type it in, you do everything right with the formula. A over sine A, B over sine B, C over sine C, and let's save you a bunch of time. You type it all in and it goes error. Why? Yes. Okay, let's talk about it further. So, do you agree that you could set these up so that you can make triangles that can't exist? I mean, you could draw a picture and then label it with sides, so it just isn't possible. That's one of the things you got to get is there is triangles they can give you that can't be done because they can't exist in the real world. I'll give you just a ridiculously extreme answer. Let's say I said this was 4 degrees. Teeny, tiny little angle. In fact, it's way too big if it's really 4 degrees. Okay. Incredibly small like that. And then I said that this side is 10 and this side is 42. And then I connect them like that. Do you think that that could work? And keep that angle the same? Well, there's some that can and some that can't. Okay. Is my scale right? No, not even close. But could I extend this out way further, like way, way, way out there? Could it possibly work? Yeah. All right. So that one's actually possible. All right. What if I made that one 42? This one's 6 degrees. If this is 6 degrees, do you notice it's hard for me to mess this up when I'm giving myself a side, an angle, and a side? What's the kind that easily gets messed up? Angle, side, side. So I was trying to pound in yesterday. Those are the kind that can easily get messed up. So do you get if I had a 6-degree angle there, and that one's 42, and I asked you to make this one 47, do you get how I would have to open up more than 6 degrees to make that work? All right, here's another one that people I think usually can see pretty well. If this is a 30-degree angle, do you get this as part of a 30, 60, 90 then? Okay, if I make it a 90 down here. And let's say this is 2. This has to be something. Remember from the 30, 60, 90, what would the have to be? 4. Okay, so what if I said that's 4 and that's only 1? You get how that triangle cannot exist? Yeah. This one's 4, then if this one's 1 and I draw it to scale, do you get how it's not even long enough to like complete? It can't finish the triangle. If this is like 1, 2, 3, 4 units long and that's 1 unit long, it's not going to be able to touch. You might say, well, why don't you just bring this other side up? Well, then it wouldn't be 30 degrees anymore, would it? So you can make triangles that can't exist. And the ones you got to watch out for are the ASS, where they give you an angle side, side. And it is ironic that those are the ones that are the pain in the butt. All right. So I'd like you to look at this with me. We're going to make the assumption for just a moment that this is going to be 30 degrees. It might not be, but let's just say it is. Would you please write that on the drawing that's on your notes? Now, I'd like to make the assumption that B is going to be 8. You might say, well, I know what A has to be. You might know what A has to be to make it a right triangle. But what I really want to know is that's an important number, but that number isn't the only number that could make this a triangle. Okay, so what are you thinking right away? What do you think A would be comfortable if it was what? 4. Because that fulfills the ratio of the 1, 2, square root of 3 triangle that we're supposed to have for a 30, 60, 90. So 4 seems like it's about right. And that would make this be a right triangle. But what if it was 5? Couldn't you still make a triangle out of it? Do you get how if this distance is 4 and I make it 5, it's going to go a little longer than that? So maybe if I show you this with this, it's like that long. Well, so sure, it's not a triangle now, but I can just swing it and go, okay, there's my 5, and now it's making a triangle this way. Or I could swing it this way and make a triangle that way. Okay, so under that scenario, I've got 2 triangles that'll work. Okay, what's the last possibility? Either it's 4 or a little more than 4. What if it's really, really, really big? What if it's like 45? Or let's make it a little less ridiculous. Let's make it like 12. Could I have it be 12 long and still connect maybe somewhere out there? Yeah, I could. It won't be a right triangle, but we don't have that rule. We don't have that obsession anymore. These don't have to be right triangles for this. All right, so basically, if it's too small is where you have the problem. Do you get if this was only like 1, it can't possibly touch? But if it's 4, it can touch once. If it's like 4.5, it could like touch twice. Up to some limit, it'd be able to touch twice. Do you get what I'm saying? And then if it gets bigger than that, it has to swing out this way, but it can still work. All right, so that's what this little theorem is telling you. And I'd like you to take a look at this, and I'm going to tell you which one to circle for each of these. If A is less than B, sine A. Well, what does that mean? For our triangle, A is 30, so it's sine of 30. What is sine of 30? You haven't memorized yet? You should. Memorize it. It's a half. So then it's B times a half. So if A is less than half of B, then it's going to be too short, right? That's that scenario. So how many answers are there? 0. So everybody circle 0. If A is, and again, if sine is sine of 30, that means this is a half. If A is equal to half of B, then how many answers do we have? 1. And by the way, it's a special one. If it's exactly equal to half of B, then it's a right triangle. Okay. What if B is kind of in between? It's bigger than it had to be, but it's less than B. That's the kind where it can make 2 triangles. You know, it's kind of that in-between size. It's kind of a little bit long, so it could go here or it could go there, but it's like it's got to be less than B to make that work. Because if it's more than B, then you're going to have to connect it over here. All right, so this scenario has 2 solutions. And the last one is, if A is greater than or equal to B, or, yeah, if side A is actually bigger than side B, that's this reddish line. If it's 8, or bigger than or equal to 8, because if it's equal to 8, you can't go back on itself and still make a triangle. It'll be right on top of itself. So if it's equal to 8 over here, it'd have to make a triangle this way, or it could be bigger than 8. And how many triangles could you make? Infinite, but how many possible solutions are there? There's only one solution after that. It's not like there's no solutions. If it was bigger than 8, like 9, then you have to go this way and you'd have one way to do it. Okay, that's a theorem. Let me show you where that theorem is. It's really scary looking. It's that one. I want you to take a moment and just read it. By the way, this is like a alpha is in Greek, and that's kind of like what we've been using for the big A. This is like a Greek C. It's like what you'd use for the big angle C. So if I draw it like this, here's little a and here's the big A, with the angle would be alpha. Where's B and C? It doesn't really matter. Any side can be any side. So we used B here, and that make this big B. And then this part must be, there's black for that, big C, little c. And this is where beta would go. It's the Greek letter B. And the Greek letter C, unfortunately, doesn't look like a C at all to us. So that Greek letter C is that little thing. It sort of looks like a scripty R. Okay. And it says let H equal C sine A. Remember, that's what we were comparing it to each time? You always do sine of the angle. Okay, so when do you really need to use this? It's something that can tell you ahead of time how many solutions your triangle is going to have. Mainly what I need you to know is if I just say, here's a problem, you need to actually be able to figure out all the triangles you could make. Is there only one? Maybe there's two that you could make. Or maybe there's no triangles you could make, given that scenario. All right, so here's a scenario. I'd like you to draw me something that has a 20-degree angle. I know you don't know exactly what 20 is, but make it your best guess on 20. And again, I'm going to focus on the ASS triangles, angle side to side. I'm going to make this side 8. I'm going to ask you, what if this side over here, I'll make it red. What if that side was 1? What's your gut feeling? How many solutions do you think you'd have? None. I agree. What if that red line was actually 6 long? So if that's 8, then this would be like 6. Do you get how that could make a triangle? How many triangles could it make? 2. What if that red line was 10 long? Could it make a triangle still? Yeah, but only 1. Getting the idea? Okay, so now let's actually do a problem. Everybody take a look at, not day 1, we already did those. By the way, we don't have time to grade last night's homework yet, but we may. Sometimes what I do is grade 2 assignments at once and pick some from this assignment and some from that assignment. I am itching to put in another one in the grade book, so probably tomorrow I'll be putting in homework. So keep doing your homework. All right, here's our first problem from today's homework. I encourage you to make the drawing kind of biggish. Even if you have to add a page in after day 2 here, where you like do more work on it, to just make the drawing kind of big, because they can be kind of confusing. If you have this really small drawing, it's really hard to see what's going on. So everybody start with alpha being a 6-degree angle. I would always just make that the angle that's closest to you as you're drawing it. Okay, and this is 6 degrees. That's a very small angle. And the side across from that is A is 57. Now, I don't know whether to draw it like out this way or in this way or straight down. I don't know. But I just would default to just kind of, don't assume it's going to be a right triangle. It rarely is. So just default to kind of swinging it out. We're going to say that's 57. And the B is 100. Notice it's an angle side-side question. So if I put this as 100, oh, which colors? Would you please use the law of sines to figure out what this angle right here would need to be? Mystery angle. Because once we have that angle, we'll be able to find the other angle easily. I'll pause for a moment while you give this a shot. Good. So I got a student to tell me that this is 10.6, and I agree. Now, here's the problem. You've got one of the two answers. 10.6 degrees is one of the two answers. What do you mean two answers? Because remember how I just told you, well, we don't know exactly how this triangle looks, so just kind of swing it out there. Do you get if it's just the right length? If it's less than 100, it could swing the other way too. Unless it made a right angle right there. Did it make a right angle right there? No, if it had made a right, if this was a 90, then that would have been the only place it could have been. If you swing it to the left or right, it wouldn't have touched. But since it's 10.6, I could have had this 57 go this way. But now think about it. If I do it that way, and I just put a 57 on it, do you get I just made an isosceles triangle, and I therefore know how long this angle is right here? What's that angle got to be? 10.6. So if this angle was 10.6 and that angle's 10.6, now don't I know what that angle is right there? Aha. So then, if that's the case, would you please figure out, if I made the triangle this way, so it's this green triangle now, would you please figure out how long this side is if I make it the short way? I already know this angle. It's really easy. It's just they add up to 180. So compare that answer with the kid next to you. Right now, we are figuring out, I'm going to call this C. Because this triangle could have been drawn two different ways. Michaela, do you know Mitch? Is that your brother? Where's he at now? Cool. Do you like it there? So Michaela, you got an idea what this angle is? Just first, what was this angle? That sounds right. Anybody verify 169.4? Okay. Okay, so we have figured out that if this angle is 10.6 because that angle was 10.6, this must be 169.4 degrees. And now this green triangle is starting to take shape, and we can do the law of sines again on it. So it doesn't even really matter which side is which. I'm going to choose to call this C to go with this C. And this 57, I'm going to call it A to go with this A. I could have called those B if I wanted to. There's not like a law that says you have to name this, the longest side has to be C or something like that. So, okay, so I'm going to do sine of 100 over sine of C. I'm wrong, sorry. 100 over sine, oh, I'm wrong again. Okay, the 100 and this go together. All right, so I'm going to go 100 over sine of 169.4. And then the others that go together would maybe be C which is this little side here, or this little side C, and this big C that would go with it. Maybe I'll need this angle too. Did anybody calculate that angle? It's got to be 4.6 degrees because it'll add up to 180 with this and this. All right, so then I'm going to use that one and the C, and I'm going to say C over sine of 4.6. There. Now I've got it so that I have only one variable and 3 numbers. And now I can solve. What'd you get? Haven't finished it? Okay, find C, everybody. How many of you have an answer already? It's only like 6 people, so I'll give you a moment. When you're done, would you please compare it to the person sitting next to you? You're trying to find this side right here. I'll make it extra black. C. Pause while you do that. What do you think? Raise your hand if you had 43.6. And pretty much everybody agrees with them. Good. Okay. So that was done by cross multiplying probably. 100 times that, which is some obscure decimal, is equal to sine times that, or sorry, C times sine of 169.4. It's all said and done. You solve for C and you get your answer. All right. What just happened there? Do you get we just found 2 different triangles that could work for this? There's 2 different triangles that could have worked for this. So when it's an angle side-side situation, and this is like 8, and this is like 12, and this is like 30 degrees, that's not my problem. This kind's easy because it's not an angle side-side. What's this one? Side angle side. Okay. Angle side-side is where it's like this. So give me your gut feeling. If this is like 4, could it work? Nope. And if that's a 30-degree angle, if it really is, do you have it in your head? What's the other side got to be to make a right triangle? 6, half of the 12. So that would have to be a 6. If this is a 6, it makes, how many solutions could it make if that's a 6? 1 triangle. There's only 1 triangle. What if it's like 7? Then you could have 2 triangles. What if it's more than 12, like 13? Then it could make 1 triangle. So what's the real only scary thing? It's if that side over here, this 6 side, if it was less than 6, then it just can't make a triangle, and then you're going to get an answer of no solution. All right. So that's the main thing we're trying to do, is look for exceptions to when this can't work. Or sometimes you will get 2 answers, because if, again, we had a length like 7, I'll show you that one more time. If this was like 7, then I could swing it in. Say the 7 could go this way and I'd have 1 answer, or that way and I'd get a different answer. And this makes an isosceles triangle. Maybe I'll make 2 of them. So that if it's 7 and you figured out this angle right here, then this angle will be the same as it, and it'll be easy to figure out the triangle within the triangle. Okay, good. So your homework for tonight is to do more problems like that. But I have gone through and noted that, unfortunately, these do take significantly longer than what they say. Like, for instance, that one said it would take 2 minutes. Don't think so. That one take a lot longer than 2 minutes because you have to find 2 answers for it. So I'm going to chop out a few because this one's a little long. Besides, we're going to spend some of our time today grading the lab. So anyway, you guys can skip number 16 and number 32. I do want you to do number 33 and number 35. It says discuss. You're not going to necessarily have anybody discuss it, but just think about it. Think about why, if you only knew the angles, why couldn't it work? And you may skip number 37 also. Okay, so those are the ones you can skip. Homework is due tomorrow. Haven't graded in a while. Probably put in a couple tomorrow, or at least 1. Last thing this hour is we need to grade the lab. So everybody get your lab up on your iPad, and that's it for the video for today.